Welcome to Managing the Future, the MIS podcast. We're really glad you could join us, especially for all you Dr. Sam Pack College of Business students and future business professionals out there. This deep dive is really designed with you in mind. Today, we're jumping into Introduction to Data Analysis with Python Part 1. It's a really key module from your textbook, Connect Master, Management Information Systems. That's the one by Richard Tedmon and H.Schuessler Wilhelm, McGraw Hill, 2024. Our mission basically is to help you build a solid foundation. We want you to get comfortable with the data analysis tools and concepts that honestly are essential for pretty much any business major now. Hopefully you'll have some aha moments today that make these sometimes complex topics feel clear and really practical for your career. And hey, before we dive in, remember to like, subscribe, follow, share, comment, all that good stuff. It helps you stay updated and keeps this conversation going.
Yeah, it's great to be digging into this. It's such a fundamental area for modern business.
Yeah.
You think about all the devices we use every day, your phone, laptop, maybe even your watch.
Right. They're everywhere.
Exactly. And they're so integrated into our lives, we often just expect them to work. You tap something, an app opens, you ask a question, you get an answer. It feels, well, almost like magic sometimes.
It really does. But, okay, thinking beyond the magic for a business student, what's the real takeaway from understanding that every single app, every function is actually a program? How does knowing that help them?
That's a really important point. Because that magic isn't magic at all, right? It's just a sequence of very precise logical instructions, what we call programs or code. A computer, at its core, is just any device that stores, retrieves, and manipulates information. Lots of it, quickly and accurately based on those coded instructions. So for you as a future business professional, this isn't just, technical trivia. It means you can start thinking about how tech can be told what to do to solve problems.
Okay. So moving beyond just using it to directing it.
Precisely. You see technology less as a fixed tool and more as something adaptable, something you can leverage strategically to achieve business goals. It's about understanding the potential for instruction.
That makes a lot of sense. And speaking of instructions, that leads us right into Python. Many of you listening have probably heard of Python. Developed back in the late 80s by Guido van Rossum, released 91. What I find interesting is that its core purpose was simplicity, making it a great first language to learn. For a business student, maybe feeling a bit intimidated by programming, why is that simple yet powerful combo so important right now?
Well, think about typical software. Excel does spreadsheets. Photoshop does images. They're specialized. Python, though, it's often described as like the ultimate digital Swiss Army knife.
Okay, I like that analogy.
Yeah, and for a business, that's huge. It means maybe using fewer different tools, maybe lower costs, and creating solutions that can adapt easily. That versatility is the real key for future business leaders. Despite maybe some old stereotypes about coding being only for tech people, Python is absolutely a critical, high-demand business tool now because it can automate so many different kinds of tasks and processes. Businesses are building all sorts of things using Python and its libraries.
The ultimate digital Swiss Army knife. I'll remember that one. Okay, let's unpack that versatility. Where does Python really shine in different business areas? Maybe start with data analysis and visualization.
Absolutely. That's a huge one. Python is fantastic for data mining, finding those hidden patterns in big data sets. It's also great for data processing, cleaning up raw data, getting it ready, and for modeling, and crucially, for visualization, making data understandable. We'll talk more about that later. To do all this, it uses these things called libraries. Think of them as toolkits. For data work, key ones are Pandas and NumPy.
Pandas, NumPy, okay.
Yeah, for manipulating and analyzing data. And then for creating charts and graphs, you've got libraries like Matplotlib and Seaborn. These libraries basically package up complex code so you don't have to write everything from scratch.
Got it. Toolkits that simplify complex tasks. So Python clearly boosts data analysis. What about finance? That often feels like a very numbers-heavy, maybe traditional field. How's Python impacting finance?
Oh, it's having a massive impact. It's used across both quantitative, the heavy math side, and qualitative processes. We're talking advanced analytics for predicting markets, making banking operations smoother, analyzing cryptocurrency, crypto too.
Definitely. And it's really fundamental to a lot of the fintech industry, financial technology, things like automating risk assessment, algorithmic trading. Python provides a real edge there.
A competitive edge. Okay. And what about accounting? I imagine efficiency is the name of the game there. Can you give an example? Like, what's a tedious accounting task Python could just take care of?
That's a perfect way to think about it. Accounting has so many tasks that are, well, frankly, time-consuming and repetitive.
Right. Reconciling huge ledger accounts. Maybe pulling together financial reports from different systems, auditing transactions for errors or fraud. Imagine instead of a person manually digging through thousands of spreadsheet rows looking for a mismatch, you have a Python script that automatically pulls the data from different places, compares it based on rules you set, and flags potential issues in, like, seconds. It's not just about speed. It's about freeing up accountants to do higher-level work. Strategic analysis, financial insights, the stuff that really adds value.
That makes perfect sense. Shifting gears again, what about sales and marketing? How does Python fit in there?
Increasingly, it's a big player, especially in digital marketing campaigns. It offers a lot of strategic advantages. One area is working with APIs, application programming interfaces.
APIs, right. Heard of those.
Yeah, they're basically how different software programs talk to each other. Python makes it easier to connect systems, pull data from, say, social media platforms or advertising tools. Then there's web scraping.
Okay, what's that exactly?
It's automating the process of extracting large amounts of data from websites. Think about automatically grabbing competitor pricing or analyzing customer reviews across dozens of sites.
Competitive intelligence.
Exactly. Huge potential there. And of course, marketing analytics, measuring how well campaigns are doing, figuring out what works, and SEO, search engine optimization.
Making websites more visible on Google and such.
Right. Python can automate analysis and tasks related to all of these, helping teams make smarter decisions and improve their impact.
Okay, so Python's reach is clearly broad. But let's face it, for many people listening, their main tool for data has probably been Microsoft Excel. It's time for the big comparison. Excel versus Python for data analysis. First, maybe just a quick refresher. What is Excel?
Sure. Microsoft Excel is, at its heart, a spreadsheet application. You've got that grid of columns and rows where you can input data, organize it, and manipulate it. It's super common for data entry, using formulas, basic analysis, making charts, even some simple automation. Very accessible.
Definitely accessible. Most of us have used it. But as you move into bigger business challenges, what are the limits you might hit with Excel? And on the other side, what makes Python initially harder?
Excel starts to struggle when data gets really big or complex. Managing tons of different spreadsheets or files can become unwieldy.
Yeah, I can imagine.
Copying and pasting complex formulas can lead to errors, which can be hard to spot. And there can be some security concerns with sharing sensitive data in Excel files. With Python, the main initial hurdle is the learning curve, especially if you've never programmed before.
Right, you have to learn the code.
Exactly. And the interface isn't as visual or immediately intuitive as Excel's grid. You're interacting through code, not clicking on cells.
Okay, let's compare them head-to-head on a few key points. First up, data analysis itself. How do they differ?
Excel gives you that visual interface. You can click, sort, filter, use built-in functions, create pivot tables fairly easily. It's great for quick looks and straightforward analysis. Python tackles analysis using those libraries we mentioned, Pandas, NumPy, and others. These libraries are packed with powerful functions for complex statistics, modeling, machine learning, tasks that go way beyond Excel's built-in capabilities.
So more horsepower in Python, basically.
Much more, especially for sophisticated analysis.
What about automation? You mentioned Excel has macros. How does that compare to Python?
Right, Excel uses VBA Visual Basic for applications for macros. These are good for automating repetitive steps within Excel. But VBA is somewhat limited. It mostly stays inside the Excel environment. Python, being a full programming language, can automate much broader workflows. It can manage entire data pipelines, pulling data from databases, cleaning it, analyzing it, sending results to another system. It handles complex calculations, machine learning tasks, things VBA just wasn't built for.
Okay. Scalability, handling large amounts of data. This seems like a big one.
It is. Excel is fine for small to maybe medium data sets. But when you get into, say, hundreds of thousands or millions of rows.
Which happens in business.
Oh, absolutely. Excel can slow down, become unresponsive, even crash. It's trying to load all that data visually. Python, however, handles massive data sets much more gracefully. It processes data programmatically, often in memory, without needing to display it all in a grid. Merging data from multiple large tables is way easier, and performance isn't really tied to the number of rows or columns in the same way.
That makes sense. It's not constrained by the visual interface. Lastly, connectivity, talking to other data sources.
Excel can connect to things like SQL databases, other workbooks, some web data. It's decent for basic importing and exporting. Python, again, is more flexible and efficient here. It has libraries to connect to almost any kind of data source, databases, APIs, cloud storage, you name it. It can also work really well with cloud platforms using things called containerized notebooks, which bundle code and data together, making analysis portable and easy to share. It just streamlines getting data in and out wherever it lives.
That's a really clear breakdown. So the message isn't dump Excel, right? It's more about recognizing when you need to step up to a more powerful tool like Python as the data and the questions get bigger.
Exactly. Excel is a fantastic tool for many things, but Python unlocks a whole new level of capability, especially for larger scale, more complex data challenges. It's about having the right tool for the job.
Okay, let's broaden the view again. Thinking about Python just on its own merits for data analysis beyond comparing it to Excel.
Right. So Python has this incredibly rich ecosystem of tools and libraries specifically for analysis. And a big part of that is visualization. It makes creating all sorts of charts, graphs, even interactive plots relatively straightforward.
And why is that visualization piece so important?
Because raw numbers or complex stats can be hard to grasp. Good visuals make insights obvious. They help decision makers understand the story the data is telling quickly and clearly so they can make informed choices. Another key thing about Python is that it's open source, meaning the language itself and many of its libraries are developed and maintained by a global community, not a single company. It's free to use, runs well on different systems like Windows and Linux, and this open nature encourages a lot of innovation and collaboration in how people approach data analysis. No expensive licenses needed.
That community support and being free is definitely a plus. This brings us to the idea of a data ecosystem. What does that term mean for a business?
A data ecosystem is basically everything an organization uses to handle data. It's the whole setup. The IT infrastructure, the databases, the software applications being used, programming languages like Python, how data is stored, everything involved in collecting, storing, analyzing, and interpreting data.
Okay, the whole picture.
Exactly. And the key thing to understand is that every organization is different. They generate different data, use it in different ways, so each data ecosystem is unique. For you as a future leader, understanding your company's ecosystem helps you see where the data flows, where the bottlenecks are, and where there are opportunities to use data more effectively.
So when a company starts a specific data project within that ecosystem, is there a typical process they follow, a kind of life cycle?
Yes, definitely. There's a generally accepted data project life cycle, usually seen as having 5 main steps. It provides structure.
Okay, what are they?
First is sensing. This is about figuring out what data you actually need, what's meaningful to collect to answer the business question you have.
Step 1, know what to look for.
Right. Step 2 is collection, gathering that data from reliable, validated sources. Third is wrangling, sometimes called data cleaning or prepping. Raw data is often messy, inconsistent. Wrangling gets it into a clean, usable format for analysis.
Probably a crucial step.
Hugely important. Garbage in, garbage out, right? Then comes analysis. Step 4, this is where you use tools, maybe Python, maybe others, to examine the clean data, find patterns, draw conclusions. And finally, step 5 is storage. How and where are you going to keep this data securely, maintain it, and make sure it's accessible for future use or audits? Hardware, software, procedures, it all fits here.
Sensing, collection, wrangling, analysis, storage. Okay, that makes sense as a flow. And all this work ultimately feeds into, what? Data-driven decision-making, DDDM.
Exactly. DDDM is the goal, really. It's about using facts, metrics, and the insights from data analysis to make strategic business decisions that help the organization reach its goals.
So moving away from just gut feelings or tradition.
Precisely. Analyzing the actual facts reveals patterns, trends, potential problems, or opportunities that intuition alone might miss. And it's becoming more and more critical because businesses are just collecting so much more data now, and it's often very complex. Relying only on gut instinct is getting riskier in today's competitive world.
Which brings us back to making that complex data understandable. You mentioned data visualization earlier. Can we circle back to that? It's more than just making charts look nice, isn't it?
Oh, absolutely. Data visualization is about the graphical, structured representation of data. Its core purpose is to make the findings from your analysis easy to understand and communicate.
Especially for people who aren't data experts themselves.
Especially then, yes. But even for analysts, visuals can reveal patterns that tables of numbers hide. There's often a simple 3-step process recommended for planning effective visualizations.
Okay.
First, really explore the data sets for patterns. Before you can visualize anything, you need to know what story you're trying to tell, what insights you've actually found through your analysis. Second, plan for the visuals. Based on the patterns in your audience, strategize how to best represent them. What kind of chart? What should be highlighted? What's the key message? And third, create the visuals. Execute your plan. Build the charts or graphics, making sure they're clear, accurate, and effectively communicate the intended insight.
Explore, plan, create. That sounds like a solid approach. Well, this has been incredibly useful, really unpacking the fundamentals in Introduction to Data Analysis with Python, Part 1 from the Connect Master. Management Information Systems text. We really hope this conversation has shed some light on why Python and these data concepts are so important for your future, whatever area of business you go into. Thanks so much for tuning in. Now we have a question for you. As you think about your own career path, which application of Python we discussed, maybe in finance, accounting, or sales and marketing, which one sparks your interest the most and why? Let us know your thoughts in the comments below. And finally, if you found this deep dive helpful, please do like, subscribe, follow, maybe share it with a friend or classmate. It really helps us keep creating this content for you. We look forward to continuing the conversation.